In this lesson, we're going to look at the patterns of end behavior in polynomial functions. So there's four main cases that we need to look at. First of all, we're going to classify our function as either having an even degree or an odd degree. So if it's like y equals x squared, that's even, where if it's y equals x cubed, that's going to be an odd function. And you've already really looked a lot at quadratics, so the nice thing is polynomial functions are going to kind of take on the same characteristics as that quadratic in the end behavior. So let's say the leading coefficient is positive, okay? You know parabolas would open upward. Well, all even functions are going to kind of do the same thing in their end behavior. It could wiggle around here in the middle, but on the ends, it's going to go up on both sides. This part is going up. So the end behavior would be the limit of f of x as x approaches a negative infinity, that goes towards positive infinity, and it goes towards positive infinity on the right. Whereas if I have a negative leading coefficient, it's going to reflect it upside down. So all even degree functions are going to look like this in the end. It's going to wiggle around here in the middle, okay? But they're both going to point downward as we go towards the ends. So my end behavior written as a limit would be the limit of f of x as x approaches negative infinity also approaches negative infinity. So it's approaching negative infinity on both the left and the right, meaning it goes down on the extreme ends. Now let's talk odd functions. So a cubic function or even a linear function is odd. What does that do at the ends? Well, this one's going to start downward. It's going to wiggle around here in the middle, change directions, but on the extreme ends, all odd degree functions will look like this on the ends. So on the left, it's approaching negative infinity, and on the right, the limit approaches positive infinity. And then if my leading coefficient is negative, and it's still odd degree, it's going to reflect. So starting up, turning around a couple of times, and then dropping on the extreme ends. So end behavior going up, end behavior going down. So how do I write the limits? It would be towards positive infinity. Oops, let me switch my tool to positive infinity and negative infinity on the right. Okay, so I'm going to give you some algebraic examples, and what I want you to do is to determine the end behavior. So I'm going to give you some tips. In this first one, first thing I do is I make sure it's in standard form. It is, meaning my highest degree is first, and I always start by analyzing my leading term because that's what's going to tell me how this graph looks. Okay, so here's what I notice. It's odd degree, and my leading coefficient is positive. So what's that mean? Well, it's going to be something like this. It's going to wiggle around in the middle, but on the ends, that's how it looks. So I often sketch it, and then I write my end behavior. So it's negative infinity on the left and positive infinity on the right. In number 2, my leading term is negative 1x squared. So this is even, but it has a negative coefficient, so this one is going to open downward. So my limits would be approaching negative infinity on both the left and right. In number 3 here, we've got to do a little bit of algebra first. It's not in standard form, so how on earth do we get the leading term? Well, that's a lot of multiplying. I got 3 binomials and a coefficient, but here's a trick, okay? If you just multiply your leading, this coefficient out front, and then the highest x in each of these binomials together, that's going to give you your leading term. So that would be negative 8x to the third. It's a shortcut because that's enough to just tell me the end behavior. So this is odd and it has a negative leading coefficient. So my end behavior or the graph, a sketch of it is going to look something like this. So it's going to approach positive infinity on the left and negative infinity on the right. So 4, let's see, using the same idea here, I would multiply 2x, x squared, and negative 7x together to get my leading term. So that's going to be negative 14x to the fourth. So even with a negative leading coefficient is going to cause it to wiggle around a little in the middle, but it's going to point down on both ends. So here are my limits. All right, this one's your turn. Pause the video, press play when you're ready to check your answer. So hopefully you found your leading term by multiplying these together to get negative 2x to the fourth. So this is going to open downward on both sides, meaning the end behavior approaches negative infinity on both the left and right.